Today on IODP Expedition 318, Wilkes Land. Exploring the history of Antarctica.
Good morning. Very happy, Co-Chief. Have you seen the ice sheet? Well, you should.
This is why we're here, to study this huge ice sheet.
Nice ice, baby!
All right there, Rob.
We've traveled all the way around the world to figure out what's going on.
It's the best day of the cruise so far.
Great cores, great scenery.
Want to see some penguins?
Yeah, it's beautiful.
Ow, ow, ow. I guess.
You can see the ice cap, 3,000 meters or whatever it is.
I hate this so much. Pretty happy about it.
There's a good balance between serious science, but also having fun while we're doing it. There's a lot of people on board who've got a good sense of humour, and I need to have my playtime. I need to be silly for a bit. I'm like a 3-year-old. Having times in the day where you're having a bit of banter with people, being a bit silly, having some fun, and then a bit of guitar at the end of the shift. If I do that, then I'm fine. I can keep doing this stuff for months. You realise to do this interview, you've got to try and get me to be serious for 10 minutes.
The job.
The organic geochemist is responsible for overseeing routine measurements. So there's a safety role for the organic geochemist, but the real scientific reason that I'm on board is to carry out measurements on biomarkers. Let's take a sample and saw it up and get it ready for biomarker analysis. The biomarkers are, the way of thinking of them is as molecular fossils. There's a lot of people working on board as micropaleontologists looking at the microscopic fossils. But I'm looking at something that is even smaller, which is fossils at the molecular level. Somewhere in this core, although we can't see them, we know there's going to be molecular fossils that were deposited at the time this sediment was forming in the Eocene, about 40 million years ago. It's a greenhouse world where there was no ice on Antarctica, and we're hoping that those biomarker fossils, we're going to be able to extract them. They're going to tell us something about the environment and the temperature of that greenhouse world.
The science.
One of the real strengths of an IODP cruise is that you have these diverse but complementary groups of specialists. So there's the physical properties people, the sedimentologists, people doing magnetism, micropaleontologists, and the geochemists. And all of us are working together to extract different but complementary data sets from the cores. And working together, they might be able to tell us quite a lot about how those sediments were deposited.
Markers that I've seen already in Site 1172, so there's...
So all of these groups are working together, and all of the individuals in the groups are providing pieces of a jigsaw puzzle. And then when we put them all together, we get a bigger environmental picture. And using all of these techniques, we can track changes in the environment. Fatty alcohols here, plant waxes also. This complementary expertise that's been gathered for this expedition has worked really well, because we've already seen on the first site, when one group or one technique has not been available or not been working, then there's always been something else there to fill in the gap or to provide us with information. So we've had periods of the cores that we were recovering where we weren't getting microfossils that could give us an age. But then we also have the paleomagnetists who are giving us an age constraint, so they can kind of fill in when the microfossils aren't providing information.
Today on Penguin TV, ocean drilling for kids.
Are you Sam? Are you Sam? Hey, I'm Sam. Which one of you birds called me big boy?
The big one did. The big one did.
Hey, calm down, calm down.
Are you the driller?
No, I'm not the driller. I'm a tool pusher for Transocean.
What is a pusher?
Tool push. Oh, we push all kinds of tools, but we also push buttons too. We try to make the management of the drilling operations go smooth. We try to interface with the scientists, keep the cores coming up good, keep the safety levels up good, and keep everybody safe.
How does it work? How's it work?
We are drilling for core samples.
Cores? Those we saw some cores we saw earlier.
Where do they come from?
Oh, these cores come from down below the seafloor, very deep.
You're good.
Yeah.
How do you get a core?
We get a core We have a core barrel already in place in the drilling string, and then we run down and retrieve it. We have a long wire on the end of a drum. It's kind of like a fishing reel. We go, you know, I know you like fishing.
Can we eat the core?
Yeah, you can't eat the core. You may try, but I don't think you'll like it. We do this thing with the fishing reel line. We retrieve the core back up when we lay this core barrel out for the scientists. But after we lay it out, we drop another core barrel so we can get back to work again while the scientists are doing their work. Then we set up so we can keep on drilling and coring ahead, try to make everybody happy.
See, I told you guys. Can you show us the core?
I can show you some cores, but we just get the cores up for the people, and later on we pass it on to the science group.
To who?
We pass it on to Christina. She's a micropaleontologist.
Is she a big guy too?
No, she's a pretty girl. She's not a big guy.
Okay.
Good.
Thanks, Ann. See you guys.
See you.
Let's go see Christina.
The mission.
One of the big unanswered questions in paleoclimatology is what's going to happen to ice? What's going to happen to sea level as we continue to see these rising levels of emissions? If we go back to the Eocene period, there was little or no ice at all on Antarctica. And we're trying to get the first sediments that are taken just close to Antarctica.
We're all here. Ice, ice, baby.
And with the biomarker measurements that I'm trying to do, we really want to extract 3 key pieces of information. What was the sea surface temperature like? What was the land temperature like? One of the biomarkers we're using comes from soil bacteria. And also, what was the vegetation and the plant types like that may have been blown off or transported from Antarctica into the ocean?
I love the smell of hydrogen sulfide in the morning. Remember, there's this one time we went coring, we brought up this core, and we didn't get any forearms. Not one stinking forearm, but that smell. It smelled like, I know, victory.
So we need to go back to this period. We need to use the Geochemists resolution to drill down, to go back in time to a period like the Eocene and see what the planet was like.
The journey.
Just another day at the office.
So on all cruises, there's a tension between the amount of time that's been allocated to the ship and the scientific objectives. And often you have a number of different research groups, and those objectives, those sites will be complementary, but sometimes they're also competing as well.
This is forecast I normally use, and I look at
this particular expedition is kind of even more complicated because of the place where we are. We've got variable ice conditions, icebergs and sea ice. There's also, you know, the very variable weather conditions. It can turn stormy very quickly in the Southern Ocean. So often the initial plan of priorities can change and become quite fluid when you're at sea.
I mean, you know, it always comes to this. It always is the same.
All right.
Yeah.
I know.
There's no wrong decisions, just decisions.
Things have to sometimes be decided on the fly.
So the decision is made, we bring the pipe home as safely as we can.
Times when the coring has slowed down, you know, you get very tense, and you get really, really happy when you achieve the objective. So yeah, definitely you get emotionally involved with the whole process of collecting the material.
Today on Gone in 30 Seconds with Stephen Picard.
Very good.
So we have gone into uncharted places when it comes to climate change. It seems as though we've been hurled back in time by some sort of geological time anomaly that has brought us back into the hothouse world off the coast of Antarctica. All sensors are on, and we're trying to understand this unusual phenomena. This enormous leap back through time was probably due to some sort of disruption along the shelf slope continuum. Truly, we have gone where no drilling bit has gone before.